That's what the Goyva Shemesh is.
And the Maslo Shemesh is the
Maslo Shemesh is just the difference between the Goyva Shemesh and the Makam Amiti. It's just a mathematical construct. And we use that number because that determines the shape of the angles that
And the Maslo Shemesh is the
Maslo Shemesh is just the difference between the Goyva Shemesh and the Makam Amiti. It's just a mathematical construct. And we use that number because that determines the shape of the angles that you're seeing if you're looking through using these two different scales. So let's use that number to look up the correction, which is the Monas Maslo.
And the Makam Shemesh Tzoi is the actual angle between the sun
and its 0 point on its circular orbit.
Okay.
We're trying to translate the numbers we have for its perfectly circular orbit, which is easy to calculate. We have a small correction to put it on our picture of the way angles we measure from our point of view. Okay, now there's an important thing that everybody has experience with, and that is if you go and you get a Hebrew Kiddush calendar or anything like that, or you're doing Tzoyim and you give out Shabbos Licht. You give out a Shabbos candle lighting calendar, right? And we know in the course of the seasons that the sun sets at different times of the day. March 21st, September 21st, the sun sets around 6 p.m. Standard time, whatever it is. Local time. We know, so for Licht is about 5:45. As you get towards the winter, like now, we have about the earliest Shabbosim now. Licht is around 4:20 or something like that. So the sun sets around 4:40 here in LA. In the middle of the summer, the deepest sunset is probably around 7:30, something like that. So we see that there's a variation of what time sunset is, right, throughout the course of the year. If the Bezdin was going to ask the Eidim in the middle of the summer, when did you see the sun and where is it? They have to calculate based on the sunset of the summertime, right? So they have to correct the calculations of the Areach and the Shemesh for the fact that sunset is going to be an hour later. Easy thing to understand about the way these things go. Remember, the sun goes around the earth on a daily basis, 24 hours, 360 degrees. That means it's 4 minutes per degree of longitude, 4 minutes of time. Okay, so if it's an hour later, so that's how it moves. That's why the time zones are 15 degrees of longitude separate from each other, etc. But anyway, so if the thing's going to be an hour later, the moon moves about how much an hour? Half a degree an hour, which is 30 chalakim, 30 minutes. So therefore, if we're going to worry about the summer, the sunset's going to be an hour later, we're going to have to add about 30 minutes of angle to the moon's position. If it's going to be the winter, we're going to subtract it. That's what that I have over here on page. I have this table over here. The Rambam has this on page 10.
Did you do page 9 again after?
Yeah, we're going to do that. I just want to show you. Page 10 is real simple. See, this is the corrections. The Rambam mentions this at the beginning of Parakid Beis. When you start to calculate the moon, he says that you got to correct it for sunset depending on the season. And he says it based on the mazolas. I just put it here for the degrees. Minus 15 to plus 15 degrees, which is right around springtime. That's going to be 0 correction because the sunset is. We're marking all this stuff from sunset in the springtime. Remember, he said it was on March 22nd. Gimel Nisan is this Iker. This Iker starting off at a place where it's around the equinox.
Isn't negative 15 the same as 345?
What?
Negative 15 is the same as 345.
Negative 15. These are chalakim. These are not. What negative 15 is? Yeah, the same as 345 degrees, right? But it just means where it is. It's just a rough area. It's about a month on either side of these things. 15 to 60 is 15 chalakim, which represent about half a degree of moon time, which is I'm sorry, which is about a quarter of a degree, which is about half an hour. That's in the late spring, early summer. Then the summer 30, which is about which is about an hour of moon time. So that hour is, the Shabbos starts an hour later, etc. That's a very simple time thing. It's fairly familiar because we're aware of how the sun sets at different times of the year, and it's an hour later in the summer, an hour earlier in the winter. That's what the Rambam was talking about in that particular halacha. All right, now let's quickly review the moon. Then we have the moon is because the moon's actual movement through the sky is very complicated. The model that the Rambam uses is the bicycle tire rotating at the end of the ribbon. The guy's carrying the bicycle tire around with the ribbon, and he's rotating it, and the moon is attached to the bicycle tire, and the moon appears to be moving back and forth just as the bicycle tire goes around. From the point of view of the observer, he sees it moving back and forth, but since he's moving anyway, he sees the bicycle tire making the moon appear to slow down and speed up. So in the course of of going around, it appears that the moon speeds up and slows down, just like it does in real life. And that's why we have this extra thing to add the extra correction. In addition to that, we have the off-center circle kind of problem.
That we add by the sun.
That add by the sun. But since the moon's movement is so crazy, you need these two corrections to approximate it. As I read you, I think a couple of days ago from the astronomy book, even the guys nowadays, there are like hundreds and hundreds of terms in the formula for the position of the moon. And because it's a very, very complicated orbit, but the Rambam has a fairly simple way of calculating it. As a matter of fact, I've written the entire calculation that the Rambam does. He writes it in a couple of prakim. I've written it here basically on 4 of these pages, a lot of which is dedicated to my poor drawings. But anyway, let's read the bottom of page 9. Since the moon moves quite, I'm sorry, I don't want to read the bottom. I want to read the top of page 9. Okay, the center of the small circle rotates about C. C is again the center of the large circle rotations, where the guy was holding the ribbon in the middle of the room. So the main thing, the mahalach and soy, which means constant speed around a circle movement. That's the big thing moving around C. The bicycle tire is being held, and the axle, and it moves around C at a constant rate. How fast does it move? Well, that's called Ensei 13 degrees, 10 minutes, 35 seconds. In 10 days, it's this much, blah, 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 blah. And at the beginning point, the Rambam's Iker, Gimel Nisan of that year, it was, where was it? 31 degrees, 1443. That's where the moon was. Okay? The bicycle tire is called the Emsa Hamaslo. That's the bicycle tire moving around to give an extra speed up and slow down to the orbit. The bicycle tire has the same kind of simple Emsoi type of rule. Constant speed. If you know where it starts, you'll know where it is later on in time. Then we'll worry about correcting our point of view, looking at both things from an offset place. So how fast does it go? 13 degrees, 354. Almost as fast as the big circle is moving. The bicycle tire is moving, so just about in 1 month, the bicycle tire goes around once. It just gives a speed up and a slow down over the course of a month. You understand?
Yeah.
It's simple. That's all it is. Okay. I mean, the mathematics is very complicated how you deal with it. But anyway, that's what it was. So we know the Emsoi kind of thing. We go to the same exercise we've always done. How fast does it move at a certain time? Where did it start? The Iker 84, 20, 28, 42. That's where your starting off point is. Now, this whole thing.
Why is the Emsa muscle
What?
for the time for the Iker so much more than the Emsa?
That's just where it was. It doesn't. That's around its own little circle. It has nothing to do with the big circle or point of view of the Earth. It's around its own little circle. And I draw that little circle too big. That little circle is really pretty small.
Yeah.
If it's only the same speed as the Urea, why is it so far ahead?
No, because
It's a different area, because it's been going for a
it's
while.
just it doesn't really matter. It's just that is not the same measurement as we see. You know, the Emsa HaYareach is close to what we see. All right, close to where we would see it. This little guy is just in its own little, it's going around its own little circle in its own little world, and where it is totally different from what we had seen. It's just it adds to speed up or slow down the movement of the moon. But it's so therefore where it was at a particular time isn't related directly to the Emsa Yareach. Okay, so then on page 10 we have this correction that we said here, that we correct the moon's position for the fact that sunset is earlier or later. We're worried about Shas Re'iyah. Shas Re'iyah is right around sunset. So once you've taken the Emsa Yareach, at whatever day you want it, based on what's on page 9 there, using the Iker and the rate of movement, then you correct it to the time of year where the sun is, right? Because the sun is what determines the seasons.
You correct it before you deal with the muscle.
Yeah. Apparently we don't care about the masl. You can ignore that correction. Okay, so now you have Emsa Yareach B'Shas Re'iyah after you make that correction. So now, after you figure out Emsa Yareach and Emsa Masl,
You add the correction to the number, to where it is.
huh?
You add the correction to the...
Yeah, you either add or subtract depending on the season where the sun is. You got to figure out where the Macham Shemesh is, because the Shemesh determines the seasons. Remember, when the sun's way up here, it's hot and when it comes back up here, it's autumn, winter, etc., etc. And then that determines the length of the day when sunset is relative to where we started. And see his Iker, Rambam was very clever about how he chose the Iker. The Iker is right around the beginning of springtime. So therefore, that's the 0 point, that's 6 p.m. kind of sunset. So therefore, he can say for summer, I'm going to add your half a degree. For winter, I'm going to subtract your half degree. By the way, if you go through the Rambam and look at these, you'll find, unfortunately, Kiddush Hachodesh and the Rambam, especially in the, I use this big old Rambam here, there's a million mistakes in the printing. They're just, errors, because a lot of the times the printers didn't know any of this stuff, and they didn't know the numbers they were writing, or the simonim they were writing for numbers are wrong. So the Rambam has corrected a lot of them, but generally speaking, you have to look at this stuff. I think I've gotten most of the corrections in my tables here that I've written down here, but there are, if you find errors in the Rambam, don't be surprised. Not the Rambam's errors, it's the printers and the other people. Likewise in Kudshim and Taras in the Rambam, they find a lot of misprints because the people who put them, the
Like
printers
what?
didn't. Huh?
Like what, for example?
Just mistakes. You see, misprints. There's typographical errors. The parts that everybody learns a lot, and the Zikin and Bayit and all this kind of stuff, everybody's constantly learning it, so they're constantly telling the printers, oh, this is a mistake, so they fix it in the next printing. But nobody, until the Rebbe was Masakin, we should learn the Rambam, the entire Rambam, who was learning Kudshim, who was learning Taras. So there's a lot of mistakes in it. The Rambam fixes a lot of them, but anyway. So meanwhile, so now after you obtain the Emsa Shemesh, Emsa Yareach, you now
Emsa Yareach B'Shas Re'iyah.
huh? Emsa Shas Re'iyah, you subtract the two of them. Right, that's called the merchak. Merchak is the distance between the sun and the moon. You can see, we saw that in our demonstration. We have the moon guy over here. How many degrees between the two of them? That's the merchak.
Subtract the sun from the moon.
Huh?
Subtract what from what?
Huh?
The Emsa Yareach B'Shas Re'iyah from the muscle or the muscle from the moon?
Subtract from the sun from the moon.
Okay. The final thing we got for the sun on page 8 at the bottom, you subtract that
The Machim HaShemesh Hemsa, you subtract that.
From the Malcolm of the Urea translate.
You subtract the Yareach from the sun or the sun from the moon? The moon from the sun, right?
You subtract the sun, the moon minus the sun. We're going to do the example. On page 12, we're going to actually do this example, which is the example that the Rambam uses for the whole calculation. However, before that, I just want to outline what the process is, okay? So basically, as a matter of fact, I'll write down the process just as the, very rough steps. And it's not, and you know what? I can't explain to you in the short time we have the reason for that this works. This is just a cookbook, okay? You want to make a cheese omelet, take 2 eggs, crack them, put some margarine in it. There's no, oh, here's a margarine. No margarine, put some margarine, put some cheese. Why do the eggs fluff up and the cheese melt? I'm not going to explain it to you. I'll explain to you that it does that and that's how it works. So here we have, step 1 is you figure out the emsa shemesh, right?
Yeah.
Then step 2 is you figure out the reach. Step 3 is you do shas re'iyah. Reach, right? That's just a simple correction. All this stuff is the same thing. Rate times time equals distance. Where do you start at the eker? Add it together, and you got it pops right out. Okay. And the Rambam is going to do 29 days after the eker.
2 is Emsa
Yeah.
and 3 is... Yeah, I know. And then
It
3
starts with an aleph, right? Yeah.
3 is that plus...
That's with the correction for sunset.
Oh, it's 2, that's page 10?
Yeah, it's just those. It's just, no, just the emsa.
Okay.
Very simple way to do it. Because what we need it for at this point is going to be very rough. Basically what it does is it takes the rough things, gets some information, makes it more accurate. Keeps on doing that. Right, so now, 4. Subtract. Moon, I'm writing this in English now, minus sun. These are the emsa places, okay?
And the moon is always going to be larger than the sun, or you can end up with a negative?
No, you can end up with negative. If it's negative, you add 360. If it's going to be less, you just add 360, because 360 is the same as 0. All right, so moon minus sun. This is called merchak, which means, obviously, the difference between the two of them, right? The distance between them.
It's like you're
No?
every word here.
Give him a chair, you can sit in a chair. All right, anyway, so you have the merchak is when we have the guys walking around, the 2 guys walking with the 2 strings. If you measure with your 2 pencils on a protractor device, if you measure the angle between them, that's the merchak. It's very simple. The merchak is what you see. I mean, that's what term is. If you have merchak of 90 degrees, you got a half moon. 180, you got a full moon, etc. When you write one right on top of the other, you got the maila, the average maila. That's, of course, these are all emsoy numbers. Now, here's the thing that drives everybody totally nuts. Okay? And that is, we double the merchak. And I'm not going to tell you why we double the merchak, because it's a purely mathematical thing, basically. So that you can use the doubled value of the merchak to look up something else. That's why. Okay.
The Rambam doubles the method?
Huh?
The Rambam doubles the method?
Yeah. It's a complicated reason with all the geometry, but I don't have enough time to explain it. It'll just be confusing to everybody. But the cookbook is you double the merchak. Okay. Now you look up. Table. I have a table on page 10. You see the table at the bottom of page 10? It sort of goes off into 2 columns.
Yeah, what are we...
Huh?
What's the merchak couple?
The merchak kafel is doubling this merchak. The merchak is moon minus sun, double it. So you get two times the moon minus sun, okay? Go into this table, and then on page 10. You take the merchak kafel. If it's between 0 and 5, you have a new number called Tosefes Hamaslo.
You still didn't do anything with the Emsa Masa.
Right. I just got the Tosefes Hamaslo. By using the merchak kafel, that is the thing, the input that you put into this table that's on the bottom of page 10. You come out with the number called merchak, called Tosefes Hamaslo. Okay. Now, what?
I think we had a 63.
What?
Method couple only gets to 63. The Mechak couple can only be up to 63?
How come it only goes up to 63?
Oh, because if the thing would be much farther than that, you wouldn't even bother doing that, any of this stuff. Yeah. The Merkach, I mean, Bechal, that's awfully wide. Anyway, the Tosefos Maslul is okay. The Tosefos Maslul, we add that to the Emtza Maslul, and we get another number, another intermediate number, which we call Maslul nothing, if I'm not mistaken.
Nothing?
Yeah, nothing.
Okay.
Okay. So you now add the Tosefos Maslul. Maslul means like path, but you know these numbers are these names are kind of confusing because they don't to Maslul. Maslul, remember, is the bicycle, how far around the bicycle wheel it is, right?
Yeah, the flag.
Right. You get then
Muscle is a small wheel?
Uh-huh.
Then you get the Manas muscle, right?
No.
Right, now once you have Maslul and Nachlain, now you can use the table on page 11. Using this Maslul and Nachlain, use that as the input to determine what the output, which is this the Manasa Maslul, or Manasa Maslul, however you want to pronounce it. You get that, and that, once you add that to the Ureach, or subtract it from the Ureach according to the rules that are given, then you have the Makama, then you have...
What are those rules?
Huh?
What are those rules?
I'll explain in a little while. Let's just put this down. All right.
You add an asmas or you subtract it?
Depends on where it is, which side of the wheel it is. Then you have Makamamiti. That's it. See, 8 simple steps.
That's it.
Okay. That gives you the whole move. Now, if you look at read briefly on page 11, it shows you a little bit about how complicated all this geometry is. That page 11, there's a diagram that I drew there, which I copied out of another book that I found. And basically, the Maslul and nothing, these are all just different slight corrections of the angle to give us where the moon is from the point of view of E. E is the guy in the earth. C is the center of the moon's Emtsoi circle. P is a point that's the same distance away from E as E is from C.
On the same line.
Huh?
On the same line or it just happens to be?
On the same line. No, it's that point on the same line. So those three.
What's P for what?
Huh? It's just for a mathematical reason. When you
That was the doubling.
when you extend those lines like that, it's not really. When you extend those lines like that, you get those 3 little lines near A and R up there on the end of the little guy. All right, so basically you do a whole bunch of trigonometry and geometry and work all this stuff out, and you get the Tosefos Maslul that we had from page 10 is the distance between A and R. Okay. A and R is the line from P through O. A is the line from E through O. So that little difference there is the Tosefos Maslul we talked about. Then the Maslul Nachlain is from A to the moon. Then
The moon is where? Oh?
the moon is where it says moon. See, it says moon there.
Okay.
Yeah. So basically all this stuff is very complicated, but the cookbook that the Rambam has cooked up for you is fairly simple. You just look up the 2 things in these 2 tables, plug them in, and you got the Makam Amiti.
And you find O by doing by the angle from C, right?
O is simply, it's your plain old, simple, old, and soy. Alright, now, everybody's probably a little bit confused. I don't blame you for being a little bit confused. but it's not that hard. Now we're going to do the example, and you'll see how it all fits together. This is the example the Rambam uses. I got lost in which parak I'm in now. But, okay. Right now we're going to do... All right, we just did basically parak 14 of 15. And the end of parak Tesvav. That's where we're now going to do that example from the end of parak Tesvav, which is the 29-day thing. And that's going to be used for the rest of the whole Kiddush Hachodesh, the 29-day thing. Okay, let's take a look at page 12. 29 days after the Iker, which was Beis Ear, tough, whatever. Okay. We got to figure out the Shemesh. Stick your fingers over to page 6 and 7.
You have that already?
Huh?
You have that already?
Yes, I do. Okay, keep a finger on page 12. You might want to work this out yourself. It's very, very simple to do the arithmetic yourself. You can work it out yourself, but you will see how brilliant and easy this is, the way the Rambam made this. I mean, I'm telling you, this is very, very complicated stuff. Nobody knows this kind of stuff. And scientists, you go to a guy who's a physicist or something like that, unless he specializes in this kind of astronomy, nobody knows this stuff. Rambam has made it so that, what?
Can you step 9 again?
Huh?
What's step 9?
Add or subtract the manas hamaslo from the makam amiti, and you get the makam soy, and you get the makam amiti.
I didn't know to add or subtract.
We'll discuss
if
that.
it's more than 180, then you can subtract.
Yeah, it depends. There's some rules here. The Rambam says them in Parak Tesvav. I don't know if I might have neglected to write them down here, which I think I possibly did. But you can see, if you look at that diagram that I made on page 11, you can see how if the thing is added or subtracted. Is the angle going to be bigger or smaller depending on where the moon is? Okay. Anyway, let's do the example and you see how simple this is really. Okay. Let's figure out the shemesh. Okay. Everybody, look at page 6. Got it? Huh? Keep your finger on page 12. Just glance at page 6. We're going to go 29 days after the Iker. What's 29 days? It's an addition of 28 degrees, 35 kalakim, 1 shniya. Okay, I wrote that down.
34.23.
Huh?
34.23.
34 what?
34.23.
Huh?
I worked it out already.
No. Okay. The Iker, 7:32:32. 7:3:32. I'm sorry. That's on page 7 in the middle. Add them together. You get 35, 38, 33. See page 12? Does everybody understand that? 32 plus 1 is 33. 33 plus 35 plus 3 is 38. 720 is 35. No carrying, nothing. That's the Emsa Shemesh for the day that we're worried about, 29 days later. Got it?
Yeah.
Simple. Next, Yereach. Go to page 9. And these are the tables that are written in the Rambam has these long things. If this is between this and this, it's this. I just copied them to a table form here on the page so that it's easier to look stuff up. Okay. All right, now, Emsa Yereach. Emsa Yereach in 29 days. How far does it move? 22,656. See that? On page 9. Where was it at the Iker? 31, 14, 43. Add them together. You get 53, 21, 39. Why is it 39? 4, 5 is 9. Because the 43 plus 56 gives you 99, right? So you have to carry,
Carries over.
So you have to carry over 1 second, one minute, take away 60, you get 39. Everybody understand Yereach and say Yereach? Simple calculation, just add them together. Rate times time is this, and what's the rate? The rate is 22,656. That's actually rate times time. And the Iker, where did you start? 31, 14, 43. There you get, now the moon Emsa Yereach was 53, 21, 39. Okay? However, When was this? We got to correct for sunset. Look at page 10. Take the Vakam Shemesh. Shemesh is around 35, 36 degrees, right? Where does it fit? It's between 15 and 60.
It's 15.
Huh?
You have to.
So use 15 halakim, 15 minutes of arc. So you add the 15 down there, and I have in a little box in the middle of page 12, 56, 36, 39. That's the Emsa Yireach B'Shas Re'iyah. Got it? Good. Simple. Now go back to page 9. Let's do the bicycle tire. That's the Emsa Maslo. 29 days. How far does it move? 18, 53, 4. Where did it start? 84, 28, 42. Add them together. Back to page 12. Add them together. 42 plus 4, 46. 28, 53. It gives you 81 really. So you have to carry over one degree over to the left, and you subtract 6. You get 21. So 84 plus 18 plus 1 is 103. So there we have the Emsa Maslo. That's the bicycle tires at 103 degrees. 21 minutes, 46. Now we do this mysterious thing called figuring out the merchak. Merchak is moon minus sun. I just copied the stuff from Yireach here. 53, 36, 39. Minus, that's the Shasari, minus the sun, 35, 38, 33. By the way, we didn't correct the sun for sunset, did we?
No.
Because the sun moves so slowly, the correction is not relevant. It won't make any difference. Okay, so we end up subtracting and we get this merchak being 1758.6. Right?
Mm-hmm.
Now, just roughly speaking, that's the distance in the angle between the sun and the moon, 17 degrees, which sounds like a lot. That's more than a day's worth of moon movement. So maybe you should be able to see the moon. The problem is that we can't really tell because these are uncorrected for the makam amiti. So therefore, we don't really. The makam amiti might subtract a couple of degrees either side of them and make it within the limits that you wouldn't be able to determine it. Okay. Now go to. So I have this merchak. What is the merchak? The difference is 1758. It's almost 18 degrees, right? 1758.6. Multiply it by 2.
Yeah.
Multiply it by 2. All right. How do you multiply? Well, you do the same thing as multiply in English, except you just, when you get over 60, you got to move stuff to the next column to the left. So 2 times 6 is 12. 2 times 58 is normally 108, right? But we subtract out 50, we got 60, we got 2 times 58 is 116. We subtract off 60, we got 56. 2 times 17 is 34. Add the carried over degree, 35 degrees, 56, 12. That's the merchak kafel. Go back to our table on page. Where is that page? 10.
10 at the bottom.
10 at the bottom. Look up that amount. Where is it in that table?
32 to 38.
Huh?
32 to 38.
Good. So it's 5 degrees is the Tesefus HaMaslu. Okay? So we add that 5 degrees to the maslu. Did we do the maslu yet?
Yeah, you did it further up.
Oh, right, all right. It was 103.21.46. Add 5 to it. You got 108.21.46. Easy. As long as you just follow the rules.
Now,
Try to figure out why it's doing
five
this.
twice?
Huh?
That's
No, just add it once. So add it to 5 to the 103, you got 108. This is exactly what the Rambam is doing, by the way, in where is it here? I should have put down the place where it is. This is in the bottom of the end of Parak Tesvav. Okay. What?
That's the bottom of 12. Page 12 is the bottom.
Yeah. Okay. All right. So now we got the Masla Nachim. Now we use this Masla Nachim as the basis for looking up something else, right? We look at, what is our instructions again? From the Masla Nachim, we use that to the table on page 11. So we find page 11.
finally the management.
Masla Nachim is 108.21.46, right? So that's over between 100 and 110.
Each one is one.
Huh? So 100 was 5 degrees 8 minutes. It reduced to 4 degrees 59, so it's about 9 halakim between the two of them, and we're 8/10 of the way through there. So we do,
One is.
huh? So for 10 degrees of maslul, the mana decreases by 9. So we get about
A little bit less than one.
huh? So we get about 5 degrees 1 chelek is the correct answer. Let's look on page 13. This is called the interpolation, where you try to figure out the value in between, knowing the two extremes and how they move, how they change between the two. You see on page 13 there?
Yeah. Where'd you get the 7 from?
Where I get the who from?
The 7.
Oh, I said because, right, for 10 degrees of maslul, the mana decreases by 9, right? So we have here, we want to find for 108, right, which is 8/10 of the way through there. So, so basically, I said that for each degree, it reduces by 0.9. So 8 times 0.9 is 0.72, right? Huh?
Say so.
Each degree is moving by how much? Each degree moves the maslul by how much? Huh?
A little bit less than one.
Look, 10 degrees of maslul, the mana decreases by 9 chalak. So every degree it's going by 0.9. It's going down by 0.9, right?
Yeah.
So 0.9, and we want to find 108, which is 8.
8 times 9 is.
8 times 9 is 72, so I just put 0.7. 7, yeah, right. So I got rid of the 0.2. So 5 degrees 8 minus 7, 7 chalakim is 5 degrees 1.
So the minus the mass will be 5/1.
Yeah, and that is the correction to the makam ha'yireach b'shas riyah, and it's subtracted here. We get 48, 35, 39, which is 48, 36 when rounded up.
Why is it subtracted?
Huh?
Why is it subtracted?
Okay. Why is it subtracted? I thought you were going to ask me that question. Okay.
Because you just say add or subtract on the board, but
Yeah, okay. All right. If you look on this picture here, on page 11, this ugly picture. Okay. If the moon is going to be to the right of the makam soy, which means it's less than the correction is going to be subtracted from the makam soy, right?
okay.
You see that? Huh?
That'll be further down.
What?
That'll be further down.
It's to the right. Yeah, this is the zero. Zero is over here. We're counting degrees this way, right? So we see, if you could see, if there were some heavenly body at the Makam Soy, and then the moon would be to the right of it. It would have less number of degrees in its position than the Makam Soy, right?
So you have to find the Makam say and see if the moon is to the right or the left of it.
Well, that comes out from this, from the way this is. Now, if the Perek Tesvav Halacha Daled, it says V'achar kach tira kama mailas hu b'maslo nothing. Im hayachis b'kuf pei. If it's less than 180, then tigra manas hamaslo hazah hanachim yemtza yireach l'shas riyah. That's the picture that I have here. You see? That's the moon is going to be to the right.
Yeah.
All right. See where I show you what masl hanachin is? It really is how far it is.
From the moon to A.
Huh? From the moon to A,
yeah.
which is the line of sight of the guy through the makam soy.
Right.
Okay? So that masl hanachin if that is to the right of it, then the guy is looking, he's going to see it less degrees than the Makamem Soy. Okay? So if it's less than 180, anywhere 180 goes from here all the way to here. 0 to 180, whatever it is. That's anywhere to the right. You're going to subtract off that correction because it's the moon is to the right of the Makam Amiti. If it's between 180 and 360 on the other side of the circle, you're going to have to add it.
So you basically draw a line through the circle that will bisect the circle.
Yeah, but there's a bunch of lines there. Let's not get too involved in the lines there. But that's the general feeling for it is that if you're on the right side of it, then the guy who's
The right
looking
side of this.
the right side of this line through the earth, through the center of
Anywhere here, I'll piece the trash.
yeah, that's right. Yeah, because you're looking
And
forward.
that's the line from the guy's perspective, not the center or the peak, but from the E.
It's from the guy going through the Makam.
From the E going through the O.
Yeah, yeah,
And the O is the Makima
and soy.
and Sai.
Yeah. So this is our correction to the Makam that gives you Makam Amiti. And then we've done it. We've done the Makam Amiti. We found the position of the Ureach, which is, as I read you in the astronomy book, one of the hardest things to do in this kind of calculation.
What comes after?
Huh?
What comes after?
Okay. Now the next thing we have to worry about is the Rosh, not the Rosh Shiva, but and there was a during the 1948 war in Eretz Yisrael, there was a kibbutz that somebody shot down an Arab airplane with a rifle. He managed somehow to shoot this rifle, and he killed the pilot or something like that, or blew out the engine or something like that, and the airplane crashed. And I think even to this day in this kibbutz, there is this airplane, the wreckage of the airplane, with as a monument to the fact that this guy. The thing is that every single guy in the kibbutz claim credit for having shut down the airplane. You go to any of these guys around and I'm the one who shot it down. They all complain. So when Rabbi Shachat came here 25 years ago or so, I believe I was the one who actually named him the Rosh. But I seem to remember me calling him the Rosh and people catching up, but I might be mistaken. Might be the other guy. Anyway, the Rosh. What did I call the Rosh the other day? The Rosh was the place, the number of degrees along the Emtzai Yareach circle, actually the true orbit of the moon, where the moon's orbit goes above the ecliptic, going north.
The 5 degrees up or down.
What?
5 degrees up or down?
Yeah, it eventually gets to 5 degrees high, and then it comes back down. Just the same as the other one goes 23 up and then down. Likewise, this one is going around that thing, which is tied at 23.5 degrees. It's going up and down. Where it goes north is called the Rosh. Where it goes south is called the Zonav. The Rosh is always 180 degrees from the Zonav.
That's 5 degrees.
Basically, this is on the line.
If you would have two rings, two hoops of the exact same size, and you could somehow fit them so that they intersected each other. One has to be a little smaller to fit in the other one. You would see that they intersect at 2 points.
But it goes at the highest point. It's 5 degrees above.
That's right.
But it's half the year. It's above.
No, every month it goes above and
Half
below.
the month. Half the month it's above.
Half the month is above, half the month is below. And the places where it intersects, is called the Rosh and the Zonav. Has the same kind of rules as all these other Emtsoi kind of things. That's the beginning of Perek Tez Zayin.
Wait, so the farthest the moon could be straight overhead is about 5 degrees north of
5 degrees north of 23 degrees.
the Tropic of Cancer?
Yes. In other words, if you have a full moon, let's say it's the first day of winter, December 21st, a full moon, if there is a full moon at that date or around that date, the moon will be the farthest north it can be. Because the sun is the farthest south, and it's on the opposite side. And if the moon at that time happens to be Reichav, which is the distance north of the ecliptic or not, it's big as Reichav of 5 degrees, it could be 28 degrees north. We're about 34 degrees. See, we're sticking up at an angle of 34 degrees, and that would be at about 28 degrees, almost overhead.
Still south.
Yeah. Now, you might say, well, I see sometimes the moon is north of me. Right? Like, if you go outside sometimes, you look to see the moon. When it's rising, it could be very far north. That's because we're sticking up on an angle, and the Earth is round, where we can sort of see
Down the hill.
north, down the hill around the curvature. It really isn't north, because when it comes straight north-south line from us, then that's where the true, then you could actually measure the angles. That's, by the way, how they figure out how big the Earth is. Huh?
I thought you
Do
guys
the
did
curvature.
Huh? No, what you do is you take a stick and you put it in the ground,
Shadow.
measure the shadow at one place. Then you go a known distance somewhere away. You measure the shadow there, north or south of it. From the difference in the shadows with trigonometry, you can figure out the size of the radius of the Earth has to be able to make that difference. But I saw this other book here where they did this kind of measurement in various places, but I don't want to go into it right now. Let's go through the Rosh here, okay? The Rosh is called in English the ascending node, N-O-D-E. Ascending means it's going north, going up. The point which the path of the moon crosses the path of the sun going north. The tail is the zone is 180 degrees the other side. Exactly opposite. The Rosh, if you go from month to month, where does the moon cross? You'll find that the value decreases. We normally count everything going this way, but the Rosh seems to move backwards. The place where it crosses, that doesn't mean the moon is going backwards. The Rosh is not where the moon is. We figured out already where the moon is going around this thing. We've done the Makam Amiti. We know that it increases every day about 13 degrees. However, the place where it crosses, that's going backwards. It's sort of like, if you ever put a plate on the ground on a table and it goes around like, it spins around. It's sort of that kind of thing. You have two plates, or the plate of the moon sort of is like rolling around, and as a result, the places where it crosses the sun's path, that moves back slowly. But the moon itself is going this way. It's just that as it comes around, the places where it's like sewing. It's going above and below. Where it comes around, that place seems to be going backwards of where it is. It isn't really the moon itself is going forwards, but the place where it crosses is going backwards.
That's every 7 years it goes back a degree or so?
Pardon?
That's every 7 years?
No, that's different. That basically is the Goiva Shemesh that we were talking about before. That's the reason for the Goiva Shemesh moving around this way is because the zero is moving backwards by the same amount. That's why the Goiva Shemesh is increasing, because the zero is going. What's the matter? You don't like that? Okay, anyway, let's just do the Rosh very quickly. It's the same kind of thing. That's what's so easy about this. Look in the middle here. This is just Perik Tazayin.
Is there an Iker?
Yep. At the Iker, way at the bottom of the page on page 13. Iker of the Rosh, the Rosh, I'm sorry, the Iker of the Rosh was at 180, 57,
So it's
28.
pretty much half.
Huh? Yeah. Okay. The movement of the Rosh, one day is 3 minutes 11 backwards. In 10 days, blah, blah, blah. 29 days, what we're worried about, 1 degree, 32.9. So let's find the Mokama Rosh 29 days after the Iker.
It never goes forward.
What?
It's going almost a whole circle forward, so it
Huh?
looks like it's moving back. If you see a wheel that's spinning really fast, it looks like it's going backwards.
You never have a negative.
What? It's sort of like going like this. And if you have a plate, you could have if you think about it, you can sort of picture it. Basically, the Rosh is going up. It starts going up north here. The moon is going around, and it comes back down, and then it comes back the next month. It's a little bit less the way it's going, because the inclination of these two orbits is like wobbling around. It's like a plate wobbling on going around, wobbling on a table, and the inclination of the moon's orbit is sort of wobbling backwards, but while the moon is moving forwards, the north-southness, the height of it is wobbling around and it's moving backwards. That's basically what it is. Simple calculation. Look at the side of the page here. Rosh, 29 days after the Iker. I wrote the Iker, copied it over there. 180, 57, 28. See it? The Rosh, 132.9. Oh, here, the way the Rambam does it makes it very easy for you. You add them the same way as you did everything, and then you subtract the whole thing from 360
Why?
to to make it negative because it moves backwards. But the Rambam put it all together so that it's just a simple cookbook. Okay? So where do you get the Rosh? 177, 30, 23. That's called Makam Rosh. Where is the Makam Zonov? If the Rosh is there? Hello? Where's the
Jack
Makam
up.
Zonov?
Jack up.
Huh?
180 around.
Jack up.
180 around. Yeah, like -3.
Why?
Here's 177. So 180 subtracted or added to that is just the opposite around, which is, say it's 357, whatever it is. Okay, anyway, next page. Page 14.
It makes it negative the way you do it in binary.
Huh?
It makes it negative the same way you do it in binary.
Right, well that's what he does. As a matter of fact, since you're a computer programmer, you can see that the way that Rambam is doing this, especially if you read inside, he's literally writing a program. If this is this, then do this. If this is this, then do this. Here's a table of values, plug them in. It's literally like the same kind of thought process that you have in writing a computer program, which is very odd because that was 850 years ago when nobody had even thought about this kind of thing. Okay, meanwhile, so now here's a picture on page 14 of illustrating the Rosh and the Zonav. The moon is going from Zonav to Rosh. Therefore, the moon is south of the sun's orbit. Oh, all right. Now, take a look at the Rosh and the Zonav. I think that's the Lashon of the Rambam. Now, let's consider the Rosh and the Zonav. Where is the Rosh? It's at 177, right? Where is the Zonav? 357. Everybody understand that?
Yeah.
Okay, easy to calculate. Where was our moon? The moon itself is at 48, right? So, where is that compared to these two things? Is it between the Rosh and the Zonav? Is it before the Rosh or is it before the
He's
Zonav?
on the day of the Acre.
Huh? What?
On
No,
the
this
day
is
of the
29 days. Where is it? Huh?
But what are we trying to do right now?
I want to find where is the moon compared to the Rosh and the Zonav. That's what this picture is. The Rosh is at 177. That's almost 180. See, it's over to the left there in the picture. The Zonav is almost at 0, right? The moon is up here.
48, yeah.
Huh?
48.
Up at 48.
That's under the sun.
All right. So what this means is the Rosh is what happens when the moon goes north, right? It's where it crosses going north. The Zonav is where it crosses going south. Since it just passed, it's after the Zonav. So that means the moon is south of the sun's orbit. You got it?
Yeah.
All right. Now, we're going to talk about what the Reichav is. The Reichav is what's called latitude. You know, latitude is the measurement of north and southness in degrees. This is latitude not from the equator, but from this ecliptic, from the sun's path. Rambam gives you, again, the same kind of thing you use for figuring out. There's a table of masluls and a table of manas masluls on page 14 here. What we're going to do is figure out how far north or south of the sun's orbit is the moon. We already know it's south because we just figured that out using our logical idea that the moon is in front of the Zonav going towards the Rosh, so it's south. How far south is it? Perek Tezayin Halacha Yotes tells you how you do it. You take the Areach, okay? I should give these steps over here for the Reichav. This is also the same kind of thing. All right, this is step 10. Calculate Rosh and Zonav. Okay? Which we know how to do. It's the same kind of business we've been doing the whole time. Simple stuff. Add the things together, you get it. Then, is it north or south? If it's between the Yereach, is it the Yereach? Is it north or south? If it's between the Zonav going towards the Rosh, it's south. If it's between the Rosh going towards the Zonav, it's north. Right? This is calculate. Yeah, I'm sorry, I can't write here. Calculate the Rosh and the Zonav. Okay, we know how to do that from the instructions on the previous page, which is page 13. Is the Yereach north or south? Use this little picture, think about it for a few minutes, and then you know it. right? Now, next thing you do is subtract.
Why do we need another latitude?
Because the latitude will also determine, the latitude and the longitude differences will determine how far away the moon is from the sun at the time that you want to see it. We're trying to figure out if it's visible or not. If it's really far away in latitude, but not so far away in longitude, those two things might add together a certain way to make it more visible. If it's south of the sun, and we're way up north looking at it.
What monosomasal is.
What?
I thought that's what monosomasal is, the difference between the moon and the sun. No?
The merchant is the difference between the moon and the sun in longitude. Or it might be the opposite way. It might be latitudinally going north, which brings it closer to the sun from our point of view. Even though the longitude line might be moving like this, so the difference might be like that, but in latitude it might be moved off like this or something. So these two things combine in a very complicated way, which the Rambam describes it in Perek Yud Zayin, and those are the conditions for deciding if it's visible or not. So you need to know the latitude as well. The latitude, again, is not latitude like on Earth. Earth's latitude is measured from the equator. In astronomy, that's called declination. It's not called latitude. Latitude in astronomy is from the ecliptic, from the sun's orbit that we've been talking about.
Same as Rama.
Huh?
Like the Rama.
That's what it is. That's what we're talking about.
No, I'm
So
saying,
Rambam gets
in
it.
astronomy, they do it the same way. They're also measured from the ecliptic.
That's where the Rambam got it from. He got it from astronomy.
No, I mean, it depends what you're talking about. It's, if you're talking about Earth latitude, then it's Earth latitude. The Rambam talks about that also. He mentions that Yerushalayim is like 34 degrees or 32 degrees, something like that. And he mentions the latitude there, where all these numbers are valid. What range of latitudes and longitudes is range? That's Earth latitude. But all this stuff now, Reichav has to do with differences from the Earth, from the moon to the sun's orbit. Let's quickly go through this. Next step: subtract moon. This is Makom Amiti minus Rosh. Okay? I don't know. I got
You always go after, let's say they're on one.
Huh?
Yeah.
Alright.
Always back to the round.
You guys have to go to for Vega now anyway, right?
Right.
Alright.
What happens to the 3?
Okay. Meanwhile, alright, so somebody be in touch with me if we're going to do this. We're going to pick up again after Yitzhak Kislev. This Hanukkah is coming up, and I don't know. Anyway, if there's any extra things with sheets, give them to me so that I can have them for next time. Alright, so meanwhile,
Mendel, what's your favorite thing about Awela? Oh, maybe we shouldn't play with this. What's your favorite thing about Awela?